Welcome. The topic we'll be discussing in this lecture is recovery from deadlock. So far we have discussed deadlock prevention technique, deadlock avoidance technique, and then allowing the system to enter into the deadlock and then detecting the deadlock. Okay. Say let us assume that deadlock is detected. Say the system is currently in the deadlock. Now how to recover from the deadlock? How to make the system come out of the deadlock? So basically there are two ways to do this. The first method is terminate some of the processes which are involved in the deadlock. The first method is to terminate some of the processes which are involved in the deadlock so that there is no circular wait. So if we break the circular wait, obviously the system will come out of the deadlock state. So that is the first method. The second method is to preempt certain resources. Is to preempt certain resources one by one in some order. Okay, so slowly you preempt few resources and check whether the system is still in the deadlock state or not. If still some of the processes are in deadlock, then preempt more resources. Continue this process until none of the uh, processes are in deadlock. Okay, so this is how deadlock can be recovered. So basically there are two ways to recover from the deadlock. The first method is by terminating some of the processes, and the second method is by preempting certain resources. Okay. First, let us see the first method. The first method is process termination. So, how the processes can be terminated? So here again, one of the way to terminate the process is just abort all deadlocked processes. So this is a very clear cut or very straightaway method which says that directly stop or abort all the deadlocked processes. So obviously if you abort all the deadlocked processes, then the system will come out of the deadlock state and none of the process will remain in deadlock state. Okay. But this is a solution which comes with a great expense. But this is a solution which comes with a great expense because we don't know what is the state of each process. Each process, how long they have computed, and how many resources they have used. Okay, all these things are just discarded. And what is their partial computations? Everything is discarded, and the processes has to once again recompute everything later when they begin after some times. Okay, so this is the first method which says that just abort all the deadlocked processes. Okay. The second method is abort one process at a time until the deadlock cycle is eliminated. Abort one process at a time until the deadlock cycle is eliminated. Okay, so this method basically, if you see the first method, in the first method the cost is very high. The first method, the first solution to recover from the deadlock comes with a huge cost. It has a huge expense. Okay, but the second method, if you see, the second method has has great overhead. Okay, the first method has a huge expense, and the second method, if you see, it has uh, a considerable overhead. Okay, it creates lot of overhead. So what kind of overhead it creates? So 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 the overhead, basically what it creates in the sense, uh, first you have to identify the process to be terminated, and then after aborting a particular process, and then after aborting a particular process, once again you should run the deadlock detection algorithm. Once again you should run the deadlock detection algorithm to check whether the system is in the deadlock state or not. So like that, Like that, after aborting every process, the deadlock algorithm must be invoked to detect whether there are some of the processes are still in deadlock state or not. Okay, so this is the overhead which is experienced or incurred by the second method. Okay, so basically these are the two ways by which processes can be terminated. Okay, to recover from the deadlock. The first method simply says just terminate all the processes, but it comes with a huge expense because the processes might have already executed for a long time. They might have partially computed their results, so now they have to give up everything, and all the process should restart. The second method says that abort one process at a time until the deadlock cycle is eliminated. But this method comes with an overhead in terms of after aborting each process, the deadlock detection algorithm should be executed again and again to find still if there is some process or in deadlock or not. Okay. And another thing is that aborting a process is not that easy. Aborting a process is not that easy. Why it is not that easy? The reason is, assume that you have a process uh, assume that you have a process say p1. Assume that there is a process p1. Okay, let us consider that this process is updating a file. This process is updating a file, and it is in the middle of updating the file. It has not completely updated, it has partially updated. Okay, and it is in the middle of updating the file. At this point of time, if the operating system aborts this process, then what will happen to the state of this file? This file will become inconsistent. This file will become inconsistent. Okay, or say that there is another process p2. There is another process p2 which is which is which is printing something on the printer. It is printing something on the printer. Okay, and now the printing is not completed, the printing is going on. Okay, at this point of time, if you abort, then what will be the state of the printer? What will be the state of the printer? In such cases, the printers should be get rolled back to some safe state. It should be rolled back to some safe state so that when other jobs comes, it will be printed in a proper way. Okay, so these kind of issues also should be taken care while aborting a process. Okay, so aborting a process is not a just a decision to just uh, close the process. Okay, before closing, currently what the process is doing, and also you have to ensure that the process is not in will not leave any resource in an inconsistent state. If if such cases are existing, then we should ensure that they are in the consistent state, and then only it should be aborted or it should be terminated. Okay, and and uh, and determining which process to be aborted and identifying which process to be aborted uh, is really a policy decision. Okay? In the first case, we are aborting all the process, but in the second case, we are aborting one by one process until the deadlock cycle is eliminated. So, identifying the correct process to be eliminated, actually, it is a policy decision. It is similar to CPU scheduling algorithms, like how we have discussed many scheduling algorithms like FCFS, round robin, shortest job first. All those are based on some policy. Some jobs or some process will get the processor first. Okay. Similarly, here also you are terminating the process. So this terminating should also based on some policy. We cannot randomly pick up a process and we cannot terminate. So based on some factors, the process should be terminated. Okay. So what is the factor? The main factor is you should terminate such a process. Uh, you should terminate a process such a way that uh, which will which will the terminating that process should result in a minimum cost. Okay, we should abort those process whose termination will incur minimum cost. If you terminate any process, some cost will be incurred. because the process is not completed. So we are terminating at some cost. Cost may be in terms of time or in terms of the computation done so far. Some loss will be there. Okay, that cost, whatever has been is going to incur, it should be minimum. So you have to identify such a process and then it should be terminated. So these are some of the factors based on which the process can be chosen for termination. Maybe you can choose a process to terminate based on the priority of the process. That is, identify the process with lowest priority and then terminate it. Okay. Or we can terminate a process depending on how long the process has computed and how much longer time it still require to complete. Okay. If a process has just now entered, it has just entered and it is staying in the system only for past 10 milliseconds. So better that process can be terminated. Okay. Or if a process is staying for a long time, but still it needs some 4 or 5 hours to complete. In that case, that process can be terminated. Okay. So like that, based on some factors, we should decide which process should be terminated, or how many resources the process is holding. Based on that also, the termination factor can be decided. Okay. If some process is holding 10 resources, then better if that process is terminated, maybe some other 10 process will get those resources and deadlock may be solved. Okay. Resources process needs to complete. How many resources the process still needs. If a process needs only one more resource to complete, better let us not terminate that. If a process still needs 5 resources to complete, that can be terminated because it needs more resources. So the less resource process, the process which needs less resources may complete quickly. How many processes will need to be terminated? That also we should identify to come out of deadlock. How many processes should be terminated? Okay. Whether the process is an interactive process or a batch process. So interactive process in the sense which will keep interacting with the user. Okay, the user input will play a major role in the process execution. Batch processes are running in the background. Okay, so so it is always better to stop a batch process because it is not going to affect any user, right? So these are some of the factors based on which a correct process can be identified for termination, right? So this is about process termination to recover from the deadlock. So we are discussing about deadlock recovery. There are two ways for deadlock recovery. One is terminate some of the processes, and the second method is preempt few resources. So we have under process termination, we have discussed two cases. Just the first case is either the first case is to abort all the deadlock process so that the system will come out of the deadlock state. But it incurs a huge cost. The second case is about one process at a time until the deadlock state is eliminated. But this comes with a huge overhead in terms of that after aborting each process, the operating system should run the recovery algorithm to check whether still some of the process were deadlocked or not. And aborting a process is not an easy decision because the process may be in between of updating a file or printing on a printer. So we have to identify the correct process to be aborted. So based on several factors, we can identify like which process to be aborted, right? The second method for uh, for recovering from the deadlock is to preempt certain resources. Preempt certain resources. So in this case, we have to select a victim. Victim in the sense which resource should be preempted. Preempt means remove a resource which is allocated to a process. So first step is select a victim. That is identify a resource which is to be preempted. Identify a resource which is allocated to some process that is to be preempted. Okay. So here also we should identify such a resource which will which will minimize the cost. Okay, we should identify such a resource that by preempting that particular resource, the cost involved will be minimum. Cost may include parameters such as number of resources the process is holding, the amount of time the process has completed so far. So all these factors, based on these factors, the cost may be decided. Okay. So we have to select a resource which is to be preempted, and identify such a resource that by preempting that resource, the cost incurred will be less. The second method is, whenever you preempt a resource, whenever you preempt a resource, then you cannot leave the process in the same state, because already the resource is allocated. So maybe the process might have did something with that resource. So we cannot leave the state of the process in the same level after preempting the resource. After preempting the resource, the process should be rolled back to some safe state. After preempting the resource, the process should be rolled back to some safe state. Okay. If you are unable to roll back to a safe state, then the process should be totally restarted. Then that particular process should be totally restarted. Okay. Always rolling back to the safe state may not be possible, because in that case, the operating system should maintain the state of every process at regular intervals, and this involves uh, a lot of data storage and maintenance from operating system side. Okay. So if a rollback to a safe state is possible, roll back. Otherwise, just restart the process from the beginning after removing a resource. Okay. Because after removing the resource, the state of the process is going to change, right? And also we should identify uh, and also we should ensure that the resource is not always picked from the resource for preemption is not always picked from the same process. And also we should ensure that the resource for preemption is not always picked from the same process. That is called as starvation. If that happens, if the resource to be preempted uh, is being picked always from the same process, then that is called a starvation. Say assume that there is a deadlock between three processes, P1, P2 and P3. Okay, there is a deadlock between three processes. They are P1, P2 and P3. Say P1 is holding some resource, P2 is holding some resource, P3 is holding some resource. Now assume that operating system is picking up, saying that P1 should release resource X. So this P1 released resource X. Okay. Now the system comes out of deadlock. Now the system comes out of deadlock. Say after some times, after X amount of time, say again there is a deadlock, and this time the deadlock is between P1, P3 and P4. This time the deadlock is between P1, P3 and P4. Now also say the operating system is what you call choosing P1 to give up the resource. Now also the operating system is identifying a resource, some other resource Ry, and it is asking the same process P1 to give up that resource. Okay. Okay. So if this is repeating, say after some other time, after some more time, say again there is a deadlock between P1, P2 and P4. Okay. So now also to recover from the deadlock, the operating system is saying that P1 should give up the resource or or Z or Z. Okay. So in this case, what happens in the sense, every time the same process is getting picked up to release a particular resource. So this case is called a starvation. In this case, what happens? P1 will never complete. P1 will never complete because it is always being asked to give up the resource whenever there is a deadlock happens. So this will lead to starvation of P1, because P1 may have to, it is not that it will never complete, it may have to wait for a long period of time before completion. So that is called as a starvation. So to avoid from starvation, we should know, we should have a maximum count on the number of rollbacks allowed for a particular process. Okay. to avoid starvation, we should have a maximum count on the number of rollbacks allowed for a particular process. Okay. So this can be easily done by including rollback in the cost factor. So whenever you calculate cost, include rollback also in the cost factor, because always the operating system will select a process for preemption in such a way that it will reduce the cost. So while calculating the cost, include the number of rollbacks also. Okay, so that if a process is rolled back 2-3 times, then its cost will increase, so that the probability of that process getting selected for preemption will reduce, right? Okay. So this is how deadlock can be recovered by preempting resources, right? So that's it about deadlock recovery. So basically there are two ways to deadlock recovery. Uh, One is by aborting the process or terminating the process. The other one is by preempting the resources. Okay. So that's it about the topic deadlocks. Okay. So we have discussed what is a deadlock, and when two processes are said to be in a deadlock state, that we have understood, and we have discussed what are the various methods of dealing with deadlock. Okay, so there are basically three ways of dealing with deadlock. The first method is to ensure that the system will never enter into the deadlock. Okay, for that can be done by using two techniques, by using deadlock prevention and by using deadlock avoidance. Deadlock prevention is done by making sure that any one of the necessary condition of the deadlock is not existing. The necessary conditions for deadlock are the necessary conditions uh, for deadlock are mutual exclusion, hold and wait, no preemption, and circular wait. Only if all these four conditions were there, then there is a deadlock. If any one of the condition is not there, then there is no deadlock. So deadlock prevention algorithm ensures that at least one of these conditions does not exist, so that the system will not enter into the deadlock state. Okay. And deadlock avoidance algorithm, we have discussed two types. One is if the number of instances of each type of resource is one, then we can avoid deadlock by using resource allocation graph. If there are more instances of resource of each type, then deadlock can be avoided by using Banker's algorithm. Okay, so that's it about deadlock detection and avoidance. And then we have discussed. Then the second method is allow the system to enter the deadlock state. Allow the system to enter the deadlock and then detect the deadlock and then recover from that. So that is the second case. So we have discussed how to detect deadlock. So that deadlock detection algorithm is also very similar to the Banker's algorithm. There is no change at all. Only thing is here we allow the system to enter into the deadlock and we frequently run the deadlock detection algorithm to check whether there is a deadlock or not. Again, deadlock detection algorithm, there are two types. The first algorithm is for when will be used when there is a single instance of each type of resource, and that is done by a graph. That is done by a graph. That is done by a particular graph which is called as wait for graph. Okay, wait for graph can be used for deadlock detection when there is only single instance of each type of resources available. And the deadlock detection algorithm can be used for deadlock detection when there is more than one instance of each type of resources available, and that algorithm is similar to that of the Banker's algorithm. And then we have discussed deadlock recovery, how to recover from the deadlock. So basically there are two ways to recover from the deadlock. Terminate some of the process is the first method. Second method is to preempt some of the resources. So this is the second way of dealing with the deadlock. The first way is to deal with the deadlock is don't allow the system to enter the deadlock. That is by using deadlock avoidance and by using deadlock prevention. The second method is allow the system to enter to the deadlock state and recover from that. The third method is ignore the problem itself. Pretend that there is no deadlock at all. Okay. Actually, most of the operating systems actually they use the third method, because the system will hardly enter into a deadlock state, right? And in a normal standalone computers, the system will enter into the deadlock state very rarely, maybe once in a year or once in 2 years. So it is better to ignore the deadlock, because otherwise the overhead involved in maintaining the deadlock detection, avoidance, and all these algorithm will be higher. So that's it about the topic deadlock. So let us stop here. Thank you.